Hello everyone, I'm Kamil Hepner and welcome. Today I'll walk you through how you can add lines to your stylized renders. As you can see, I've added them here to our previous hatching shader. So if you are new, follow up with the tutorial about the hatching and we will pick up from there and add the lines right now. As you can see, the lines added extra dimension to our render, which make it look super nice and stylized, and enjoy watching. All right, before we jump into Unreal and start working on the shader, let's have a quick breakdown of few line drawings and see what basically is a line and what kind of properties our line shader should have. Let's maybe start with this part here. To add depth into drawings, one of the techniques is to draw lines closer to the camera or viewer, however you will say it, are thicker, and the lines of objects much further are thinner. So this is really important. That's something which we'll replicate in a shader. So when the object is closer to us, the line is thicker, and when the objects are further away, lines are thinner or they even disappear, right? Another interesting thing is that the lines kind of go around the contours of objects, or we can say features. Like for example, here on the lips, we already implemented that part where the cross-hatching lines kind of bending around the surface to add this three-dimensionality to it. We did that in a hatching shader tutorial, but we can see here that the line goes around the lips. We just have a brief look. The line is a little bit irregular. This is super cool, and I think that brings us here to this drawing that lines are quite irregular. We can see that the color sometimes go outside of the line contour, and that's basically it. I think this is a good place to start with, so we will try to get the lines thicker, irregular, and see how does it look, okay? All right, so this is the final results of our shader, and I'm using here a static version of a hatching shader. You can find it on my YouTube how you can convert that one where we move the camera, the hatching texture was changing, and if you want to grab the files, you can grab it from my Ko-fi page as well if you want to follow up and you don't want to redo everything by yourself. And there's also hatching textures and etc. But let's get back to our lines. As you can see here, for example, we have a lines closer to the camera much thicker, lines further thinner, and as well we have a little bit of a squiggliness in the lines, just have a little bit of a randomness to it, right? I make it more like a drawing. So the whole thing based on simplified version of edge detection algorithm, I can say. Before we'll start jumping into a material builder and show you how you can build this material, it's basically post-process material. So let me just maybe show you step by steps what's happening here. So here I have a post-process volume, and I'm gonna turn off the paper. I'm gonna turn off the hatching lines. As you can see, this is the lines which we have been talking about. This is what we're gonna recreate. And let me just hide the squiggliness, and we will start with that. We're gonna first create the lines like this, okay? So how we can detect those lines? It's pretty simple. Let's jump to GIMP and let's talk about edge detection and how there is a very simple algorithm to do that. Here I just have a screenshot of, and all what we need to do is basically shift the picture by 1 pixel in every direction. So it's a left, right, up and down, and subtracted from the original picture. So first of all, this is our original render, right? And then I have a version shifted by 1 pixel to the right. You can see, right? It's just shifted by 1 pixel. Cool. And when we have that version shifted by 1 pixel, all what we need to do is just subtract it from the original picture. And let me show you what's happened when you just go and subtract it. So they should be subtract somewhere here. Here you go. You see, it starts kind of just picking up the edges. And we do that for every direction. We do it for right, left, top, and down. You can also do it in 45 degrees, but to be honest, it's not really necessary in our case because we just want to do a simple case. And you can always extend it, right? And that looks like a little bit of an edge detection algorithm. Now, let's say, because you can see a colors, we work in the colors, what we can do, we can also desaturate original image and desaturate that one which been shifted. And now you can see we start getting some sort of lines, right? The thing is, we're not gonna work on the image like that with all the shading and everything. What we will do, we'll take the deep buffer and we'll shift the deep buffer, okay, left and right, up and down. By doing this, we basically gonna get the edges, and we can actually simulate it. Why not? Let's just go back here. All right, so this is our deep buffer, the same thing. Let's just grab a screen and let's bring it there. So this is deep buffer. Now duplicate the layer, shift it by 1 pixel to the right and subtract it. And here you go. You can see here we got the edge. So we're gonna do it in every direction, okay? Let me turn off the debuffer visualization. Good. I have adjusted the details on a separated panel here. Okay, let's start clean. All right. Let's just remove all the materials from post-process. And the hatching post-process material you have in the latest video from the YouTube, which you can watch. As well, if you don't want to recreate the whole look, you can grab the files from my Ko-fi page if you like to. All right. First, let's start by creating lines just to detect all the lines. All right. Let's create a new material. I will call it PP lines video. Let's change our material domain to the post process, and we can change before tone mapping. So as I said, what we do, we operate on a deep buffer. So let's get a scene texture and let's get the deep buffer. Okay, here you go. Let's connect it to emissive color. So if you haven't followed our previous tutorials, just to let you know, the eye adaptation is turned off for this project because we want to have a control about the lighting. So the eye adaptation is turned off and the auto exposure, etc. is turned off. So watch the previous tutorials if you're curious how to do it. If you want, you can grab the files from a Ko-fi page if you don't want to recreate everything. Okay, cool. So this is our deep buffer here, and it's very bright. We can multiply by some small numbers so you can see it a little bit better. It's just a visualization thing. We're not going to use this small value. And let's connect it to emissive color. And yeah, and you can see, so this is our deep buffer. And we want to desaturate it some sort of way. So because deep buffer is black and white anyway, so we're just gonna operate on a scalar values. Let's use a mask to mask it. component mask, here you go, and let's use the red channel here. And as you remember, we will subtract it from shifted by 1 pixel the buffer, right? And we're gonna get to this shift, how to do it in a second. Let's just subtract one from another. So now when we subtract, they're unchanged, but when we subtract one from another, obviously you will get 0, right? There's nothingness because we subtract the same one. Now we need to modify the UV for this one, so we'll basically shift it only by 1 pixel, no matter the size of the window and etc. There isn't a way in Unreal to just simply say shift this buffer by 1 pixel. Although it's pretty easy, but sometimes confusing for people. Let me just show you. As you know, we can query the information from the buffers based on UVs, right? But UVs are from 0 to 1, starting with upper left corner. This is a 0, 0. And here is like 1, 0. Here is 1, 1. And here is a 0, 1. Right? So we need to know the value of the shift in UV, no matter how big is the size of an image, to shift it just by 1 pixel, right? And luckily, we have already here very easy access to this information of what's the UV value for 1 pixel shift. And that gives us the inverse size. Inverse size is basically 1 divided by the size of an image in the X and the Y direction, right? Awesome. So let's start with the up and down section first, okay? We have an inverse scale here. Let us just the Y direction, positive one from it, multiply it. And just one thing, let's say, I will show it to you, debug scalar values, and we can just put the inverse size and connect it to emissive color. All right, I need to be, sorry, that's a vector because it's an X and Y, so we can debug two float values. Fantastic. And let's connect it to the emissive color. Okay, so this is UV values to shift a picture by 1 pixel. And then you can multiply as many pixels you want to shift it. Just multiply by 1, 2, 3, or 4. Okay. And those values change depends on the size of the picture, right? So if I just go back here, and if we just go to post-process volume, and we start it clean, let's add a lines here. Remember, it was called lines video. Yep. And let's just get back here. Let's save it. And we get back here. Cool. We have different values here and different values here because it's a different size of the windows. Great. So no matter what the size of the window will be, we can also do play in editor window. And I think that's now being pretty clear that those values change. And now we know if we want to just shift it by 1 pixel, we know exact value of the UV. Great. Let's get back to our shader. Let's remove the debug. So now we just want a one direction and it's a positive Y. And let's just add it to the texture coordinate. Okay. And we'll plug it into the second one. As you remember, this is the original one and this is the shifted one, right? And now if we display the emissive color, we should be able to see something. And let's just have a check. Inverse size, all good, all looking great. Let's get back here. And it's fantastic. So it actually does what it's supposed to do. It's shifting images, and we are detecting now the faces facing up. Let's just repeat the same thing. Let's just clean up a little bit, make it a little bit more spacious. And let's just duplicate the same thing for the minus y direction. Okay, here you go, and we just need to change here to -1. Great. And since we are subtracting those two as well, I don't know why I did not copy those two nodes. Here you go. We'll connect the colors here. Okay. And we'll just add. Great. And let's have a look. Let's connect it to an emissive color. Great. As you can see, we start getting some edges here. When we're shifting image up and down, we start getting some edges. And let's just save it. Let's go back to a hatching video. Yep, we start see some edges, and we currently see only like top and bottom edges. We don't see left and right. So the next step is just to add left and right. And as you can imagine, it's very simple. We basically change the value of this vector from 0, 1 to 1, 0, and then -1, 0. Okay, so I'm just gonna do it. And we add all of them together. All right, and this is, we can say this is the basics of the edge detection based on a debuffer. So you're getting outlines of your objects, and it's really cool. It doesn't need to be included in your shaders, in your materials for objects. You can just use it as a post-process material. So it's really powerful, very easy to set up, and it's a global thing. Now, as you can see, there is our sky sphere. It's visible. It has the polygons from the sky sphere are basically visible. So what we will do, we'll deal with it a little bit later. Okay, we're just gonna remove it from the debuffer. It's easy to do. Now what we'll deal with the thickness of lines. We want the lines closer to us to be thicker and lines further away to be thinner. We'll use debuffer to change the thickness of lines, right? So let's copy our debuffer node, scene texture depth, and let's copy the mask. No, this is mask. So we want to work on a scalar values, not on a vectors, because that's returned as a vector, even if it's black and white. And let's just connect this one to emissive color. And just for visualization, let's just multiply it for a second, and let's just multiply it by some smaller value. The reason why it's white, if you don't know, the thing is, it gives us, if I just emissive color. Oh, a little bit too big value. So everything, in Unreal, which makes sense, everything what is above value 1 will be white, right? So if it's 2, it's going to be white, and etc, etc. And the debuffer, the way how it works, pixel has a value of how far from a camera it is, right? So you can imagine, we are like, if we are that close, we are almost like, let's say 80 units, right? And if we are like that far, we just like 2000 units, right? So you can imagine why everything is white. And just to bring it down, we just divide it by 100 or multiply by 0.001. Okay, cool. And I just for visualization. So we're gonna use these values to multiply our line thickness, okay, and control it. So let's just do some measurements. Maybe should we? Let's just jump from the top. Let's just hold the middle mouse button, and I can see. Okay, I can see that the house or whatever scene I'm working in is like 1000 units depth, right? So that kind of gives me indication that I would like the lines, if camera is here, I would like these lines to be thicker and this line to be thinner. So I would like everything happens to like in a 1000 or maybe 700 units, okay? So this is like a first measurement to know how much depth on what scale of a depth you will like control it. Good. We can keep multiply just for visualization, but first thing what we want to do, we want to clamp it, okay? We want to clamp our debuffer value. So let's clamp it. I want to clamp it from let's say, so the closest value will be 100. So that's when the lines will be the thickest. And the thinnest line will start happening at 600. Okay, just for now. And then we can expose as a parameters and we can adjust it. So the lines, if there's a distance 700 or 800, they will just stay the same. Okay, they'll just be the thinnest line. And the thickest, if we are like at the distance of 800 units, like super close to the object, it's still gonna be the same thickness, okay? Right. Now, we would like to remap those values. So we will get the value from something as we can use as a multiplier. So let's do it. And let's type remap value range. Now I'm gonna disconnect this guy here. Okay. And as a min low, we can use the same values here. And target low and high, let's set it to 1 for time of being, okay? So you plug both those values to low and high. And now we can use it as a multiplier to define how thick the line will be. And the way how you do it, you just multiply basically the shift of how many pixels the debuffer been shifted. So if it was just shift by 1 pixel, the lines are 1 pixel thick. But when we multiply it by 4 and the pixels, it was like a 4 pixel shift, the line will be 4 pixel thick, okay? So we need to inject it in those places here. So that's pretty easy. Let's just add one multiplier here to just show you how those work. Okay. And we just put that out from this range here. So I'm gonna quickly redo it for all of those. Great. So let's save it and let's have a look how does it look. Okay, let's just be sure that we have it connected to emissive color. Great. And let's have a look. Let's just go back to our perspective with the Alt G. So now you can see that, let me just double check if we are using our video to be sure. Of course we does. Okay, so now you can see our lines. And because we didn't change the value yet, so all the lines are 1 pixel thick. But let's just zoom in here on the stair so we can see that effect. And now if you increase the value of low, so what is closer to us, to let's say 6, right? And let's just save it. You will see a nice effect here that the lines here closer to us are thicker, right? And to disable this glowing bloom effect is pretty simple. We just select our post-process volume, go to details and type bloom. Yep, here you go. And you can just leave the method as a standard, doesn't matter, but we're just gonna put the intensity to 0. Okay, great. And now you can see closer to the camera, we have our lines thicker, and further it goes, we have our lines thinner. So according to our basically a research which we did in a breakdown of a style. That's given a nice depth to our render. But there's a few more interesting things which we need to do. As you can see here, we have a box, and box have an edge here, obviously, but there's no line created on the edge. So generally speaking, we have outlines created right now, but we do not have visible very well the lines or changes happens on the objects. Like there is a box here, and I would like to see a little bit of a line here and here as well. So there is a way to do it. We basically do the same thing. We search for edges, but we search it on normal, basically normal buffer. Let me just show you how those look. War normal displays basically a value of which direction the current pixels are facing, and we can use this buffer to get some extra lines. Like you see, there will be some variations here between those values here, and there will be some extra lines showing up to give a little bit of a definition in our picture. So let me show you how to do it. It's pretty simple to implement that part. We just need to copy that whole tree here. I mean the whole graph, maybe not the tree. And just move it down a little bit. We will use the same logic of multiplying by a distance. So that's we're gonna keep for sure. We just need to plug it back here. And the one difference is that instead of using depth buffer here, we're gonna use the world normal. So we can select all of those nodes with using scene depth. Here you go. And switch it to world normal. And you can see all of them now are switched to world normal. And we can have a quick debug view. How does it look? And let's connect it to emissive color. Save it. Yep. So that gives us more of a polygon outlines, right? That looks pretty cool. So, yep, we save this. Good. Oh, we just need to go to lit mode. Great. As you can see now, we're getting some polygons visible. And when we combine it with our original outlines, that would give us more of a nice definitions here. So that's super awesome. Let's just add those two together. Actually, there's one mistake here when I'm looking at it. As you can see, what's happening here, we're using a mask for world normal. So we only working with the red colors. That's why when we looking, we don't see from polygons from every angle, I could say. What we need to do, we need to change those masks to basically RGB. Yep. Yes, we're gonna work with the RGB edge detection right now. Then we're gonna desaturate it and then add it back, right? So this is important step, which we just skip. Okay, let's have a look. And this is invert size, that's okay. So RGB. All of those looks good. Yeah, we're adding them. And now you can see we are detecting much more edges. Yep. So this is the save. And let's go back here. Yep, now you can see we're detecting edges here and here, which is awesome. And you know, that could be your stylized look. For example, if you're going for some sort of cyberpunk neo synth wave looking, and you know, you can go and explore it much more. It actually looks pretty cool. But while we're going for more like a cartoony hand-drawn style, so the next step for us to do is basically desaturate it when it comes out from here. We can't grab just R value or G or something because they're different values. So desaturation is the best way to go. Great, and we plug it to the add. And we're connecting this one to emissive color and save it. The bloom is visible here, that's all right. But when we go back to our view, yep, let's save once again. Yep, here you go. Now we can see the edges showing up. For example, here in the box, you can see that the edges are showing up here. We can crank it up, those values, so they're much more pronounced than just like a gentle indication. What I also like to do, I like to just increase the contrast between the lines. So the reason behind that is if you have objects with lots of normal changes like rocks or something like that, that could be quite handy if you just increase the contrast. So we just only see the strongest line, not all the lines. And you know what, just the last thing to do, let's just clamp it just in case. It'll be from 0 to 1. And then we'll connect it to emissive color. Save it. So the previously was bloom here so pronounced because we use the super high values above the 1. And now we just like get everything nice from 0 to 1. Great. Let's have a look at our box. Yep, we can see some lines there. And let's just also do the power on our lines from on the outlines lines. It just cleans up some lines which are not really important. Basically increase the contrast between them. Great, let's save it. Let's have a look here. Yeah, there's a little change here, like inside the pot. There's only important lines now visible. And also you can see, whoa, as also you can see that now we can see more of a definition of those lines on the box. And the cool thing is, as you can see here, these lines closer to us in the camera are thicker and lines further away from a camera are thinner. There is still one of an issue when there's a few lines overlapping, they still become quite thick, but that's okay. That's just more, we can look at it as some sort of like a shadow areas and things like that. So that's okay. But generally speaking, the further you look, the lines are thinner, closer you look, the lines are thicker. And that's great. So this is our basically line rendering, right? And now what we need to do, I would say, squigglify those lines. Make them just more irregular, okay? And that will be done in another post-process material. And I will show you how you can do it, because we need to do it all over the whole picture, okay? It's pretty simple. Let's start by creating new post-process material, which will basically squigglify the lines. And we go create a material. Let's call it PP. Let's call it lines mix video. Great. Let's jump inside, set it to post-process material and change it to before tone mapping. We need to have some sort of noise texture, world align noise texture. So I will bring texture object here, not the sampler. You will see in a second why it's a texture object. And I'm gonna use one of my Perlin noises when I just generated. By the way, if you would like to get some noise textures generated by me, just jump in this link. I have a few cool textures over there for you to just get literally in the price of a coffee. So it's really worth. There's a few Perlin noises, some other algorithms, unique, like they're not, you can't Google them, I just generate them. So it's a good thing that you have something more unique than everyone else. And we're gonna create now world align texture. The reason why we are using world align texture is that when we moving camera in a scene, we don't want the lines to just change completely, to move all the time. That's a little bit too much for our look. So that's why we're using world align texture. And also, as you know, because we are using a static version of a hatching shader, which is using world align textures as well. So if you haven't followed the video about the hatching shader, take a look there. And there's also somewhere a video here about a static version of it. Cool. And let's connect this one to output. Let's save it. As you can see here, we're having this Perlin noise here in a world align fashion, right? Let's apply a shader. Here you go. Let's add another one. I'll be on top. Asset reference, line mix video. Cool. Just save it. And you can see here we have that noise. We need to, first of all, change the size of a noise. So it's much bigger, not just this very grainy one. We can do it very easily just by changing the texture size. Let's go with value 200, for example. Let's make a vector out of it. Make float 3. That's fantastic. Let's obviously plug all of those 3 values. And let's plug it to a texture size. By the way, by the default, some people miss that the texture size is 64 by 64. It's not 1 by 1. So just as a reminder, and now save it. And yeah, I think that's where we're gonna start. I tested that value before and was okay. You can always adjust it as you like to, but this is where we will start. And we use this noise to squigglify the lines. And how we'll do it, it's pretty simple. First of all, we're gonna get the result from the previous post-process material. So scene texture, great, and let's choose here the post-process input 0. And if we plug into the color, we save it, and we go to a hatching, of course, video, this is the line, so great. And now we're gonna use this noise to offset the UVs, and that's gonna give us nice, like squiggly lines, okay? So let's mask just one value. Let's say we'll choose the red. So we use a component mask. And we're gonna use a constant bias. The reason why, I'm gonna explain to you in a second, by scale. Sorry, constant bias scales. The reason why, because the parallel noise which I generated, the values go from 0 to 1. And I would like to have values going from -1 to 1, because sometimes I would like offset UVs in the one direction, sometimes in another direction, right? This node will do that for us. First of all, what we'll do, from the current value, we're gonna subtract -0.5. So the first, when we subtracted -0.5, we have a values going from -0.5 to 0.5. All what we need to do at the end is just multiply it by 2. And this node does that for us in a one node, right? You can do it separately, or you can just use this node. So it does first operation, which is just addition, and second operation is multiplication, right? So we just subtract 0.5 and then multiply it by 2. And now we're gonna have a values from -1 to 1, okay? And now it's super simple as you imagine. We just get the texture coordinates. Here you go. We add it together and we plug in it there. Here you go. And now you can see a freaky image. You can see, right? Yeah, it's crazy. Yeah. The reason why it's like that, because the offset is too big. We can't offset just UVs by 1 and -1. It's a huge value. What is happening is like literally shifting the whole picture over, right? So we need to just at the end, just multiply it by smaller value. And that will be like value defining how much the lines are squigglified, I would say, okay? Let's see, 0.1, let's plug it there. Let's save it. As you can also see here, we can have this kind of underwater look, something like that, which is, if you animate it, looks pretty awesome. Let's get back here, and voila, we have our squiggly lines. And the cool thing is, like, when we are moving camera, because we're using waterline textures, the lines are not changing that much. They just change a little bit, but not too much, not to distract the viewer. Great. And if you want, you can change the type of a noise to get different patterns, more aggressive, you know, like much sharper turns or things like that. Super good. Or you can just change the multiply value, just, you know, make it less squiggly or much more squiggly. It's totally up to you. So this is how we do that. Now, what I like to do when I'm working with the post-process materials, and I'll give you that trick, is basically setting up priority. Let me just select the material output here. You go, and let's type priority. This basically defines which one is the first one material in the chain, which one is the last one. I like to control it by these values. It's totally up to you. So I know that the lines are the first one, so I leave it 0. Then I know that the mix lines is the second one, so I give it value 1. So higher the value, the later in a chain that material will be post-processed. So I will give it 1 here, okay? And I like to control it explicitly like that, just to avoid any issues and any problems with it later. Since we have that, that's super awesome. And now all what's left, it's basically combine it with our hatching shader. Although there's last thing, is that annoying sky sphere in the background. We can just get rid of it very easily. this sphere is pretty far from a camera. It's like 8,000 units or even above that. And let's just go back to our lines, and we can just get rid of it just by adding an if statement. I know not that many people use the if statements, but actually very powerful and quick. Let me just connect them. Okay. Now, actually, I don't want to connect it from here. I want to connect it directly from here. I want to know the clean value of a distance, right? I want to just know and just cut it out at some point. So if the distance value is, and let's say B will be 8,000, because we want anything above 8,000, we just want to be black, okay? Cut out completely, 0. So if A is greater than B, so the distance is greater than 8,000, we just want the value to be 0. Pretty simple. If it's equal or lower, we just want our calculations for the line thickness, and we have a line thickness between 1 and 6, so it's not a 0. And yeah, that's it. You can save it now, and you can even see here in a preview that the sky sphere is not visible anymore. And it depends on your project, you know, but at some point you will cut off the lines, because if the objects are very, very tiny in the background, yeah, that they'll be just thickness of a line at the end of the day. So you just want to cut it off at some point. Alright, so now we just need to combine it with our hatching texture, and that's pretty easy to do. Let me just open the hatching shader before the changes, so you can see how was it. It was basically taking a post-process input 0, whatever there was. I think that was the paper, as far as I remember in that case, and just blending it with a black color. And we need to change that part here. If you want to know how to build this shader, have a look at my channel. I just explained it over there. Okay, let's close this one. Let me just show you the modify one, and we're just gonna look at it. Cool. Yep, and it's pretty simple. I'm gonna explain it to you. So as you can see here, what we do, we have a static version of our hatching shader. Let me just show you how does it look if we just plug this part here. Now actually, let me just plug this one here. So I'm not getting any other post-process material, so that's just the hatching part. And let's just go to the post-process volume. And just one last thing, what I like to do is like select the materials, go to priority, and yeah, the priority is 3. I would set it to 2, because 0 is the lines mix is a 1, and this one will be 2. We are adding it to our list here as a reference. Let's add the hatching video. This is that one which we just modified, and doesn't matter where we put it on a stack right now. So as you remember, this is our hatching texture. I can say a mask, right? And what we need to do now, we just need to add the lines to this. That's pretty simple, and that's what we're doing here. We are bringing a previous post process, which is a squiggly lines, right? We adding them together here, and we can just display this one here. Save it. Let's have a look. Yep, you can see now we have it with the lines and looks super nice. Great. So since we have that, the last thing what we need to do is just apply our paper shader. And a paper shader, it just got modified a little bit comparison to previous videos. Let me just show it to you. And I will just walk you through. It's pretty simple. I'm not gonna recreate it from scratch because you watched the previous videos, but let me just show it to you. Let me just show it. So we're getting a texture coordinates. Here we have our paper texture, which you can get from coffee page. We just multiply by 0.5, so it wouldn't be that pronounced. We just use a cheap contrast to just get like less contrasty. We just want to have a little bit of a feeling. And now we are bringing all of those black and white lines, basically white lines, and we're using that as an alpha to mix it with a black color and the paper. That's it. And I just set it up priority to a highest one in this one. And what we do here, we just add our shader here, paper, video. I like to put it on top. Here you go. And yeah, voila, that's our lines. It looks super awesome. And if you want to have a more squiggly lines or less, you can just now expose some parameters here. Like for example, if you want the lines to be thicker, closer to the camera, you can just change these values. These values here allow you to define when the lines will become thicker, when the lines will become thinner. And squiggliness, we can control it here. We can just do multiply. We can just increase multiply, and that would just make the lines more squiggly. Let's have a look. You see, like the lines are like much more squigglier. It depends what kind of look you are looking for. That could be, it's more of your like artistic choice, but it could be something what you want. If you want to have a more frequency, you can just change the size of a texture. That's totally up to you, but that's how you can add some outlines and lines to our stylized looks to just give it more of a depth to it. Thank you for listening. I hope you enjoyed the short video.